In this video, I'd like to demo how you can use Kامسول multiphysics to model Joule heating. So we've got this fuse sitting on a simple circuit board. I intend to run a current of 15 amps from left to right in this picture. So from the pink patch, up to and through the fuse, and down through the via to the ground plane. Or rather, I'll assign a 15 amp input current to the patch and ground to the ground plane, and Kامسول will find out the rest for us. This includes the resulting Joule heating and temperature increase. The question we'll hopefully be able to answer by the end is, will it blow? Now, the fuse is effectively just an aluminum thread running through a vacuum tube. Aluminum has a melting point of 933 Kelvin, so what the question boils down to in the end is whether or not the temperature in the thread will exceed 933 Kelvin. We will also find the voltage drop across the circuit and a whole lot of other interesting results. Now let's bring up Kامsól. On our left, there is the model builder, which is where we'll spend most of our time modeling. So far there isn't much in here, but we'll constantly be adding things. By the end of the session, it will contain a complete record of the model. We've got a graphics window, as you can see, and some message bars as well. The model wizard right here in the center takes you through the first steps of each model. And right now it wants to know what space dimension we will use. I'll pick 3D and hit the next arrow. For the next choice, there's the physics. And there's a whole lot of different kinds of physics here. There's AC and DC currents and electromagnetic fields. There's various kinds of acoustics. There's transport and chemical reactions, etc., etc. Remember that we want the fuse to heat up, so we should find something in heat transfer. Under heat transfer, I'll browse down to electromagnetic heating and finally Joule heating. Joule heating just so happens to contain everything we'll need for this model, but you can actually mix and match any number of interfaces. If, for example, you want to model thermal expansion due to this heating, you can add a structural mechanics interface, either now or later on. But for this model, let's go for just Joule heating. I'll hit the next arrow again. And that brings us to the final step in the model wizard, which is the study type selection. You can select the time-dependent study if you want to see how the temperature evolves with time. You can do a frequency transient study if you want to keep the temperature as time-dependent but look at AC instead of DC currents. For now though, we are only interested in the temperature after a long time, so let's select stationary. And that's the final step in the model wizard. I'll hit the finish flag. Now look at this. The model builder has now been filled with nodes for definitions, geometry, materials, physics, that's Joule heating in our case, mesh, study, and results. I'm going to go top down, starting with geometry, and just fill all these nodes with content. So let's right click on the geometry node. Doing so, I get various options for drawing, such as cylinder, sphere, and lots of other primitives, 2D works, planes, and a little bit of everything. But I can also choose to import the geometry, and that's what I'll do. Kامsól supports most common CAD formats. After selecting fuse, which is my geometry, I'll just click the import button, and here it is. Let's hit the wireframe button in here so that we can see what goes on the inside. And there's the fuse wire. So we've got the geometry. We'll need some materials. You can create your own materials, that's this first selection, or you can use the ones from our built-in material library, and I'll do that. So let's pick as the first material aluminum. I'll right click on that and add it to the model. Now this being the first material that we're using in the model, it will automatically apply everywhere. And I don't quite want everything to be aluminum, so I'll just hit this little broomstick and delete it. Now let's add aluminum only to those places where we want it to apply. I'll select this wire leading up to the fuse, the heatsink of the fuse, the actual fuse wire, the second heatsink, and finally the wire leading down to the circuit board. Those are now all aluminum. The next material will be copper. I'll find it right here. I'll add it to the model. And I would like copper to reside in the patch leading up to the fuse, in the via, and finally in the ground plane. As the last material in our model, I'd like to add a material called FR4, and that's commonly used in circuit boards. So this is what applies to the non-conductive parts of the circuit board, right here. Right, beautiful. We got our materials and we have the geometry obviously. So what's next? Well, it's the physics.